Here I have my pick set up to output 100 Hertz frequency. So when I plug this in, you should see 100 Hertz over here. Here, using both INT interrupts and timer 0 interrupts, I have created a program that outputs 100 Hertz frequency and calculates the frequency in the frequency column. Here I'll start my speaker and reset the value, and it should calculate 100 Hertz every time. It's getting the same value, so it is staying at 100 Hertz, but here I can reset it again. 100 Hertz still. 100 Hertz. And 100 Hertz. Still reading 100 Hertz over here. Here, using timer 0 interrupts and INT interrupts, I have a period calculator. Pressing RB1 will reset the value to 0, and releasing it will let it to recalculate. Currently it is recalculating over and over and over, but once I plug in my speaker, you can hear the tone. It should have a period of 0.01 seconds. And zero it out, calculates 1, 0 it out, calculates 1, and for a 100 Hertz signal, it will stabilize. 100 Hertz should have a period of 0.01 seconds. Here is my 4-key piano that I made using timer interrupts 0, 1, 2, 3. Depending on which button I push, it'll output a specific frequency, as you can see it on the left. So here's me testing it. You can also play 2 frequencies at one time. Here I am using pulse width modulation to control the brightnesses of the LEDs in port C. Here you can see I have RC2 set to 90% on, RC1 set to 50% on, RC0 set to 10% on, and I'll have a couple more examples. Here's another example with RC2 being 30% on, RC1 being 90% on, and RC0 being 40% on. It's a little hard to tell, not in person, but the left and right are dimmer than the middle. Here's an example with all of them at 10%. And last, I have an example with all of them set to 100%.